Hello, 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 and welcome back to Shiksha DaCosta. Today we are going to be starting a unit on applying probability. In this unit, we're going to learn how to determine and represent probability in all its various forms. We'll also learn to identify it and interpret its application. So when can we actually use it in real life? How do you know you're successful at these? When you can identify examples of the use of probability in the media and various ways in which that probability is represented, when you can determine something called the theoretical probability of an event, and when you can represent that in all sorts of ways, when you can perform a probability experiment, then take the results, represent them with a frequency distribution, and then use that to determine what is the experimental probability of that event. When you can compare using an investigation, the theoretical probability with that experimental probability, and you can explain to anybody why would those be different? What's the difference between theoretical and experimental probability? Getting closer to the end of our success criteria here, when you can determine using through an investigation, the tendency that experimental probability has to approach, to get closer and closer to theoretical probability as you try the experiment many more times. And finally, and this is probably the most important one, interpret that information that involves using probability and statistics, especially when it's given to you in the media, and make connections between what does probability mean and what is the difference and what are the similarities between that and the word statistics. So, I want to ask you a question just to get your mind in the right idea for what probability represents. It's a very simple question. What are the chances of getting a result of 2 if my experiment or the thing that I'm doing involves a spinner wheel? So your first instinct might be to say 25%. But of course, when we talk about what are the chances, there are many different ways of representing probability, and percentage is only one of them. Can you think of any other ways to represent probability as well? What are the other ways we could answer this question? What are the chances of getting a result of 2? Another way that you might represent it would be maybe 1/4 or 1/4. And you certainly can see that happen here, right? 2 is one of the 4 options here. Now this experiment is using a spinner wheel, but there's lots of different other ways which we can talk about running a probability experiment or running a game of chance. Another way might be to throw a dice. This is something called a D4, a 4-sided dice. You roll this, and then whatever number ends up being on top, that's the number that you've rolled. Again, looking at this, what would be the chances of getting a result of 2? In this case, the chances of rolling a 2 or getting a result of 2 is still 1/4, because one of these 4 corners of this die are going to be at the top, and that's the number that we have rolled. What about if we had 4 balls numbered 1, 2, 3, and 4, and they were all inside a bag just like this, and you sort of dip your hand into the bag and you pulled a ball out at random? Again, what are the chances of getting a result of 2? In this case, just like in the others, there are 4 equally likely outcomes. Just like the others, the chances of getting a 2 here are also 25%, because only one of those numbers is matching our desired result. So in these 3 different types of experiments, these probability trials, there are 4 equally likely outcomes. And there's no other possibilities, so 4 is the number of equal pieces that would make up something called a probability space. And we'll talk about that in just a minute, but you can imagine it's sort of like a spinner wheel. Each of these numbers take up the same amount of area of this probability wheel. And there's no other possible numbers that this arrow can land on. So this is something like we would call this maybe a probability space. These probability space is the space that all possible possibilities, I guess, all the possibilities are accounted for. For when we're thinking about the concept of probability space, it's important to note that this arrow cannot land exactly in between the lines. It's either going to land on one side or the other. And I know that, technically you might say, like, okay, what if it lands at exactly 90 degrees? For our purposes, we're going to imagine that it cannot do that. Okay, we're going to say that we're using probability space to try to understand probability. And in order for us to do that, we have to sort of imagine that, okay, it'll never actually land exactly here. It might be like one atom to the left or one atom to the right, but it's going to land on either one or two. It'll never land in the middle. Of course, 3 or 4 are also options, but it also won't land exactly on this line or this line either. One of these outcomes, in each of these 3 experiments, there's only one outcome that matches my criteria of getting a 2. So the way I would represent this probability is 1 out of 4. There's one outcome that matches my criteria out of 4 equally likely outcomes. There's 1, 2, 3, 4. There's on the dice, there are 4 outcomes. There are 4 balls in the bag. But only one of any of these matches what I want, which is a 2. The way we would write this, if this was an equation, it would be the numerator is the number of outcomes that meet our desired result, and the denominator is the number of total equally likely outcomes in the probability space. So there are 4 outcomes, that's in total, and only one of them, the 2, matches my criteria. So that's how we represent probability. Of course, anything that's represented as a fraction can be represented as a decimal. And so we can divide 1 over 4. 1 divided by 4 would give you 0.25. And we can convert any decimal to a percentage by multiplying by 100, or just by moving the decimal point over 2 spaces to the right. So this would be the same thing as 25%. It's really important to know that, in an experiment like this, it's very easy to see, 25% is the chances I'm going to get a 2. But probability experiments are going to get more complicated, and we need a way to come up with this number, this percentage, that doesn't just rely on our intuition. And this is how we do it. We write it as a fraction first, the number of outcomes that we're looking for out of all the total possible equally likely outcomes. And then we divide those to turn it into a decimal, and then multiply by 100 to turn it into a percentage. So for what this means, what does 25% mean? The word cent is a Latin prefix that means 100, like centuries, 100 years. There are 100 cents in a dollar. A centennial is a 100th anniversary. So per 100, that's what this means. That means that for every 100 attempts that we make, it's probable that we're going to get 25 results that are a 2. So that's what this unit is going to be about. Probability is a way that we measure the likelihood of an event happening when we're making a certain number of attempts or trials. A probability space is a geometric, so using geometry, a geometric representation of all the different possible outcomes. Probability can be expressed and measured as either a ratio, as a fraction, as a decimal, or as a percentage. And we express it as P of x. Now, usually you're used to this being multiplication, right, when there's brackets and variables. But this is not multiplication. This is saying P of x, and this means the probability of x, where x is the event that we're tracking. So in our experiment today, we tried to find P of 2. What is the probability of getting a 2? Theoretical probability is the probability that you might calculate or estimate is going to happen, but experimental probability is a probability that is based on the results of an experiment or a test that you actually did, instead of just relying on, your estimations or calculations. An example here. Let's examine this very special dice. It's not a regular dice. It doesn't have the numbers 1 through 6 on it. It's a special dice. It's got 1, 2, 3, 3, 3, 1. So this is sort of what that dice might look like. Okay, there's 3 3s, there's 2 1s, and there's only 1 2. What could the probability space actually look like? So if I wanted to express the probability space of this question A, I could draw a sort of like a pie chart. I could draw a circle that looks like this. And that way I would see that, how would I didn't just break it up into 3 even pieces, even though there's only 3 different possibilities, 1, 2, and 3, because there are more ones, there's 2 1s and only 1 2, then I would break this circle up in a way that the area of the 1 is double the area of the 2. And there are 6 total outcomes, and half of them, 1, 2, 3, 3 of them are 3s. So the area of the probability space that should be taken up by the outcome 3 needs to be half. Half the total probability space is occupied by this outcome. I could also describe a probability space not using a circle graph, because a circle graph might be a little bit easy to look at and understand, but it is a bit difficult to draw very accurately. Like this was just a guess from me. I don't know that this is exactly 1/6 of the space. Another easier way to draw probability space might be to use a rectangle. And so I'm going to draw this big rectangle here, and I'm going to cut it up into 6 equal pieces, and then I'm going to color them in. So that would be the area of a 1. Notice it is still 2 out of 6 sections. I could color one of these in blue to represent 2, and the other 3 I could color them in to represent 3. In this case, the probability space, the area of the big rectangle is still represents all the different possibilities, whereas the area of the blue, it only takes up the same amount of probability space as the outcome 2 does in the circle. Either way, whichever way you want to go, the probability of rolling a 2, if we look at the probability space, it's divided into 6 equal parts, and only one of those parts matches our criteria. So the probability is 1. The probability of rolling a 2, remember this is not multiplication, this is not like a variable, this is probability of x, and in this case x is 2. The probability of rolling a 2 is 1 out of 6, because there are 6 equally likely outcomes, and only one of them matches our criteria. So this is the probability expressed as a fraction. Of course, some of us, myself included, definitely like percentages better than fractions. So I will divide 1 divided by 6, and I'll get 0.166666. And I'll multiply that by 100 to turn it into a percentage. So the probability of rolling a 2 is about 16.66666%. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.